By the year 2027, putting a brand new traditional diesel semi-truck on the road is going to become, well, a massive regulatory liability.
Yeah, it really is.
The days of a heavy-duty rig rolling down the highway, blowing black exhaust, they're functionally dead at this point. And that invisible 80,000-pound freight network that brings you absolutely everything you own, from the device you're using right now to the materials building the room you're sitting in, it's about to undergo the most expensive, brutal, and just foundational transformation in its history.
Oh, absolutely.
So welcome to this deep dive. Today, we are analyzing a comprehensive piece of source material. It's titled The Green Road: Sustainability and Innovation in Modern Trucking. And our mission today is to figure out how environmental sustainability in the logistics sector has completely morphed.
Right, it's not what it used to be.
Exactly. It is no longer a voluntary PR stunt or some, feel-good corporate initiative. It has become a high-stakes operational necessity that dictates the survival of everyone. I mean, everyone, from the independent owner-operator all the way up to massive retail shippers. Okay, let's unpack this.
It really is a phenomenal shift in market mechanics. If we look at the core arguments presented in our material, true knowledge of this transition requires connecting the dots between environmental science and, well, hardcore corporate economics.
Right.
We're looking at a scenario where reducing greenhouse gas emissions and improving air quality are no longer just ecological goals. They've been weaponized into the new baseline metrics for business survival.
Yeah, and looking at the U.S. Clean Air Act, which serves as the foundation here, it seems like the EPA's new guidelines are the real trigger. I mean, they aren't just adjusting targets. They are effectively legislating the internal combustion engine out of existence over the next decade.
Yes, that's exactly what's happening.
The EPA Clean Trucks Plan introduces these incredibly strict emissions standards starting with model year 2027 vehicles. And in manufacturing cycles, that is practically tomorrow.
It is tomorrow. And the regulatory pressure really compounds when you look at the heavy-duty greenhouse gas standards, specifically Phase 3.
Oh, right, Phase 3.
Yeah, this rule explicitly targets trucks and tractor-trailers for model years 2027 through 2032. The mechanism here is designed to force a drastic reduction in greenhouse gases by aggressively encouraging long-term fleet electrification.
Which is a huge undertaking.
Massive. But the federal level is only half the story.
Yeah.
You have state-level mandates operating simultaneously, most notably the Advanced Clean Trucks Rule, or the ACT.
The ACT. Yeah.
Right, and the ACT rule doesn't just ask for better fuel efficiency. It physically requires manufacturers to hit escalating sales percentages of zero-emission trucks. If we connect this to the bigger picture, these aren't long-term abstract aspirations.
They're immediate.
Exactly. These mandates are legally forcing the entire market to abandon traditional diesel to make concrete, measurable progress toward net zero transportation economies.
Okay, but wait, I have to push back on the economic reality of this, because the sheer capital expenditure, the CapEx required to meet these Phase 3 deadlines by 2027, it just seems completely disconnected from how trucking actually operates.
It does seem that way on paper, sure.
Right, because the freight market is notoriously fragmented. A massive percentage of carriers are small fleets operating on razor-thin margins. So if the government is suddenly forcing them to adopt incredibly expensive zero-emission technology, how does a standard carrier absorb that financial shock without simply going bankrupt?
Well, that tension right there between capital expenditure and operating margin, that is the central economic crisis of this transition.
Yeah, I would imagine.
To offset those heavy upfront burdens, the regulatory frameworks are bundled with significant economic mechanisms. First, there is robust access to government grants, tax incentives, and dedicated funding programs.
So the government is helping foot the bill?
Partially, yes. They're designed specifically to help fleet operators absorb the massive price tag of vehicle acquisition and the necessary facility upgrades. But the survival strategy relies on a total shift in how a trucking company calculates its operating expenses, or OPEX.
Right, because an electric truck costs drastically less to run on a per-mile basis once you actually manage to buy it.
Precisely. The upfront CapEx is undeniably painful, but companies are modeling for a lower total cost of ownership over the vehicle's lifespan.
Oh, I see.
By transitioning away from diesel, you are eliminating one of the most volatile expenses in a carrier's ledger. Electricity prices are far more stable than diesel fuel. Furthermore, the maintenance profile of an electric drivetrain is fundamentally different.
Because there are fewer moving parts.
Exactly. Without internal combustion, you eliminate complex transmissions, oil changes, and exhaust after-treatment systems. The intended economic design is that these long-term operational savings keep the carriers financially viable while complying with the new mandates.
Okay, so since regulations like the ACT rule mandate the actual sale of zero-emission trucks, the immediate industry pivot is toward electric vehicles, or EVs. But moving from the regulatory theory to the physical highway, well, it reveals a massive operational gap.
A huge gap.
Right, because putting a colossal battery pack inside a heavy-duty big rig demands an entirely different operating environment than electrifying a passenger vehicle. You can't just throw an EV truck onto a random cross-country route.
No, you really can't. The physics and the battery limitations dictate exactly where these EVs can be deployed successfully right now.
And where is that?
Well, the data highlights that EV fleets are finding rapid success in very specific, highly controlled applications. We're talking regional hauls, last-mile delivery, urban freight, and port drayage.
Port drayage, okay.
Yeah, these are operational environments where the trucks run predictable, shorter routes and return to a centralized depot every single day to charge. Port drayage is actually the perfect example of why the mechanics of EVs thrive in specific niches. Moving shipping containers in and out of a congested port involves hours of stop-and-go driving and just waiting in lines.
Which is an absolute nightmare for a traditional diesel engine. I mean, idling in a port line burns expensive fuel while moving exactly 0 miles. It completely destroys the truck's efficiency metrics.
And generating massive amounts of localized air pollution at the same time. But an EV motor fundamentally reverses that inefficiency.
Oh, really?
Yeah, an electric truck doesn't consume energy while idling in that same line. Furthermore, all of that low-speed stop-and-go movement allows the EV to utilize regenerative braking.
Right, the regen.
Every time the driver steps on the brake, the electric motor reverses its function, capturing that kinetic energy and feeding it back into the battery. So the very environment that destroys a diesel engine's efficiency actually maximizes electric trucks' range.
Wow. And it fundamentally changes the environment inside the cab for the driver, too.
Yeah.
I mean, you are trading a massive vibrating diesel block for a near-silent electric motor. The reduction in localized engine noise, the elimination of cabin vibration, and zero exposure to diesel exhaust that drastically reduces driver fatigue.
Is a massive quality of life improvement.
It really is. But here's where it gets really interesting. Adapting to these electric trucks requires an entirely new mindset. It is very much like the historical shift from an old, reliable flip phone to an early generation smartphone.
Oh, that's a great way to put it. The jump in capability is massive, but it comes with a steep operational learning curve.
Exactly. With a traditional diesel truck, the flip phone, the technology is highly forgiving. You have massive range, you know exactly how the mechanical parts behave, and if you run low on fuel, well, there is a sprawling century-old infrastructure of truck stops ready to fill you up in 15 minutes.
Right, it's everywhere.
You don't have to overthink it. Now, you introduce the EV truck, the early smartphone. The ride is brilliantly smooth, the technology is futuristic, but suddenly you are managing intense range anxiety. Oh, definitely. You have to meticulously plan your daily routing based purely on where the kilowatt hours are available. The battery drains differently based on the ambient temperature or, how heavy the freight is. It requires a level of daily hypervigilant management that simply didn't exist in the diesel era.
And that daily management completely redefines the role of the operator.
Yeah.
Drivers are no longer just steering freight from point A to point B. They have to act as energy managers. They require deep training to understand battery thermal management, charging protocols, and how to physically drive in a way that maximizes that regenerative braking we discussed.
Right.
But your smartphone analogy also perfectly isolates the systemic bottleneck threatening this entire transition. The physical charging infrastructure simply does not exist at the scale needed to support heavy freight.
Yeah, because you cannot just pull an 80,000-pound electric rig into a standard rest stop and plug it into a level 2 charger. These trucks require massive, megawatt-level chargers.
Exactly. And delivering that level of power requires entirely new electrical substations. Industry analysis constantly points to this grid limitation as the single biggest barrier to large-scale EV adoption.
It's just not ready.
It's really not. Fleets might have the capital to buy the trucks, but local utility companies often quote timelines of several years just to upgrade the local grid enough to handle a depot full of charging heavy-duty vehicles. The trucks are outpacing the grid's physical capacity.
Which creates a massive structural problem. The EPA Phase 3 standards and the 2027 deadlines are approaching rapidly, but the grid infrastructure and the vehicle ranges cannot support a total switch to electric.
No, they can't.
So the industry cannot simply halt operations while they wait for substations to be built. They need an intermediate step to remain compliant while keeping the supply chain moving. They need a bridge.
And that bridge is heavily reliant on alternative fuels. While EV technology and the electrical grid slowly mature, fleets are utilizing near-term solutions like renewable diesel, biodiesel, compressed natural gas, renewable natural gas, and even early-stage hydrogen fuel cells.
Okay.
These fuels serve as the pragmatic middle ground between the heavy pollution of traditional petroleum and the massive infrastructure demands of total electrification.
Let's look at the mechanics of why these are easier to implement right now. Take renewable diesel and biodiesel, for example.
Sure.
These are completely different chemical compounds, even though they both aim to replace standard petroleum. Renewable diesel is refined through hydrotreating, making it chemically identical to traditional diesel.
Right, which is key.
Yeah, that means a fleet owner can use it as a complete drop-in fuel. They don't have to modify their massive, expensive internal combustion engines, and they can use the exact same fueling pumps they already have.
Contrast that with biodiesel, which is created through a different chemical process and often has to be blended with traditional diesel to prevent gelling in cold weather or, degrading older engine components.
Ah, I see.
Then you have compressed natural gas, or CNG, and renewable natural gas, RNG. RNG is particularly fascinating because it is captured from agricultural waste or landfills.
Wait, really? Landfill?
Yeah, you're taking methane that would otherwise escape into the atmosphere and burning it for fuel. These alternative fuels offer immediate reductions in greenhouse gas emissions and lower the industry's reliance on petroleum without requiring the paralyzing facility overhauls that an EV depot demands.
But, okay, this triggers a glaring question. If these alternative fuels, especially something like renewable diesel or RNG, are so highly practical, utilizing existing internal combustion infrastructure while significantly lowering carbon output, why are they legally designated as a temporary bridge?
That's the big question.
Yeah, I mean, why aren't they considered the final sustainable destination for the trucking industry?
It comes down to the exact uncompromising language of the regulatory frameworks.
The fine print.
Exactly. Alternative fuels are highly effective at lowering life cycle emissions. But the ultimate legal destination, written into the EPA Phase 3 standards and the Advanced Clean Trucks rule, mandates zero tailpipe emissions.
That's zero.
Zero. Burning renewable diesel still produces tailpipe exhaust. It is a necessary immediate strategy to survive the tightening emissions targets of the next few years, but it fundamentally cannot cross the ultimate legal finish line, which currently only recognizes battery electric or hydrogen fuel cell technology.
Okay, so carriers are forced to invest heavily in bridge fuels and technologies, fully aware that they will eventually have to secure the massive capital required for the final leap to zero-emission fleets.
Unfortunately, yes.
Which brings us to a fascinating economic reality. How do companies actually fund this? How do trucking companies, freight brokers, and the massive retailers who hire them turn these brutal environmental mandates into a tangible financial advantage?
Well, this is where we see the emergence of highly complex, entirely new economies within the logistics sector. The two primary mechanisms outlined are carbon credits and comprehensive sustainability certification programs.
Let's analyze the carbon markets first.
Okay, so the framework defines a single carbon credit as representing 1 metric ton of carbon dioxide, or its equivalent in other greenhouse gases, that has been reduced, avoided, or physically removed from the atmosphere.
This creates an incredible market dynamic because a trucking company isn't just selling the physical movement of freight anymore. They can actually generate and sell an invisible commodity.
Exactly.
If a carrier switches a portion of their fleet to electric, or even if they just deploy advanced aerodynamic fairings to drastically cut their diesel burn, they are reducing their emissions below the regulatory baseline. They can take those quantified reductions, package them as carbon credits, and sell them on the open market to entirely different industries, like, say, a massive tech company trying to offset the carbon footprint of its server farms.
And this raises an important question about market transparency and verification. While the financial incentive is brilliant in theory, the implementation divides the industry.
How so?
Well, proponents view these carbon markets as vital, necessary tools for rapid decarbonization, providing crucial revenue to fund further green investments. However, skeptics highlight the immense administrative and bureaucratic burden of proving additionality.
Additionality.
Yes, verifying that the emission reduction wouldn't have happened anyway without the credit incentive. Tracking, auditing, and legally verifying every metric ton of invisible gas requires a level of administrative overhead that many small and mid-sized carriers simply cannot afford to manage.
That sounds exhausting.
It is. Furthermore, regulatory uncertainty means the financial value of those credits could plummet if the legal frameworks shift.
Yeah, it sounds like a bureaucratic nightmare for a logistics company just trying to survive the daily grind of moving freight. But the source material details a secondary program that operates much more seamlessly within the daily business of securing freight contracts, right? The EPA SmartWay program.
Yes, Merwin.
SmartWay functions as a benchmarking tool, helping carriers measure their emissions, track fuel efficiency, and prove their operational performance to the market. It is essentially a corporate nutrition label for freight.
And the mechanics of how that reporting is used have completely changed the power dynamics of freight procurement.
Because massive retailers and consumer brands don't just care about securing the cheapest cost per mile anymore.
No, not at all.
They are under intense public and regulatory pressure to meet their own ESG targets, environmental, social, and governance goals. They need to hand their investors and shareholders an ironclad report proving their entire supply chain is environmentally healthy. SmartWay gives these large corporate shippers the exact carbon calories of the trucking carrier they just hired.
And that data flows directly through the freight brokers, who sit between the carriers and the shippers.
Right.
Freight brokers are now facing intense pressure from their massive retail clients to provide granular, exact transportation emissions reports for every single load.
Wow.
Because the SmartWay program provides a standardized metric to track a carrier's sustainability performance, a high score has evolved into a massive competitive advantage.
So it actually wins them business.
Exactly. If a carrier has adopted bridge fuels, improved their routing efficiency, and secured a strong SmartWay certification, they will consistently win more lucrative freight contracts from large shippers who desperately need to lower their supply chain emissions. Environmental reporting is no longer a marketing bullet point. It is a primary procurement metric deciding who gets the business.
Okay, let me synthesize the sheer scale of this transformation. We are looking at a critical global industry that is being heavily squeezed by aggressive EPA mandates and state laws to systematically eliminate the internal combustion engine. To comply, they are wrestling with the staggering capital costs and severe grid infrastructure limits of electric vehicles, forcing a massive retraining of their workforce. And because the EV transition is currently bottlenecked by physical power grids, the industry is heavily utilizing drop-in alternative fuels like renewable diesel as a pragmatic bridge.
Yes.
And amidst all this operational chaos, they are forced to navigate an entirely new, highly bureaucratic financial ecosystem of carbon credits and ESG nutrition labels just to remain competitive and win freight contracts from major retailers.
That's the reality of the market today.
So what does this all mean? For you, listening right now, it means that the next time you click buy online and a package arrives at your doorstep, you should realize that the truck that brought it to you is actively fighting on the front lines of the largest historical transformation in industrial transport.
Absolutely.
We are watching an ecosystem where sustainability has shifted from a noble idea into the brutal, absolute core of day-to-day survival.
I will leave you with a final thought to mull over, building directly on the severe grid infrastructure limits we discussed.
Okay.
If managing local utility grids, mitigating peak charging times, and physically acquiring the megawatt-level power needed for these facilities is truly the hardest and most expensive part of this entire transition, will the successful, dominant trucking companies of the next decade actually look more like massive real estate and energy conglomerates than traditional freight haulers?
Oh, wow.
If controlling the power grid becomes the only way to guarantee the movement of freight, the fundamental business model of trucking changes entirely. It is a fascinating question to consider the next time you pass a big rig on the highway.
The invisible network is evolving into something entirely new. Thank you for joining us on this deep dive.